This is SpaceTime, Series 28, Episode 91, for broadcast on the 30th of July 2025. Coming up on SpaceTime, clear evidence that dark energy might be changing. A new study shows that molten magma probably persisted on the surface of the moon for much longer than expected. And Europe developing a new space weather early warning system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The largest supernova dataset ever compiled has provided astronomers with some tantalizing hints that a mysterious force known as dark energy may be changing over time. Scientists know very little about dark energy, hence the term dark. It appears to be a sort of vacuum energy, acting opposite to gravity, and it's causing the universe's rate of expansion out from the Big Bang 13.8 billion years ago to accelerate. And that acceleration is important because it will determine the ultimate fate of the cosmos and everything in it. In order to study and map dark energy, astronomers map the light coming from thermonuclear or Type 1a supernovae. These involve the dramatic destruction of a white dwarf star, that's the stellar corpse of a once sun-like star at the end of its life. Now, usually these stellar cores would simply just gradually fade away over trillions of years. However, if the white dwarf's in a binary system with a nearby companion star, its gravity can drag material off that binary partner. And if it drags enough material off its companion, it reaches a sort of tipping point known as the Chandrasekhar limit, roughly 1.44 times the mass of our Sun, and it's a point which will cause the white dwarf to undergo a thermonuclear or Type 1a supernova explosion. These explosions completely destroy the star. And because they always occur when the star reaches the same mass and has the same degree of luminosity, astronomers can use the inverse square law to turn them into cosmic distance markers, allowing them to determine how far away the explosion was. It's just like looking at a row of streetlights down a road and knowing that because they're all the same intrinsic brightness, the fainter they appear, the further away they must be. By measuring the distance to these supernovae, astronomers were able to measure how fast the universe was expanding. And they discovered that instead of slowing down or staying constant, the universe was expanding at an ever-increasing rate. Now, since the late 1990s, dozens of experiments using different telescopes and techniques have captured and published more than 2,000 Type 1a supernova events. But without correcting for differences between different telescopes and techniques, using supernovae from separate experiments is often a bit like comparing apples to oranges. In order to unite supernovae and provide a more precise measurement of dark energy's role in our universe, astronomers have now compiled the largest standardized dataset of Type 1a supernovae ever made. The compilation is called the Union 3, and it was put together by the International Supernova Cosmology Project, which is led by the Department of Energy's Lawrence Berkeley National Laboratory. The analysis of this new supernova dataset is hinting that dark energy may be evolving over time. In other words, unlike gravity, it's not a constant. The findings reported in the Astrophysical Journal aren't yet strong enough to conclusively state that dark energy has started weakening. But they are pointing in the same direction as a separate analysis by the Dark Energy Spectroscopic Instrument. These two complementary approaches, seeing similar results using different techniques, do have astronomers intrigued. Moreover, a partially independent result from another supernova analysis, which includes supernovae from the Department of Energy-led Dark Energy Survey, also appears to be supporting the same conclusion. One of the Union 3 study's authors, Saul Perlmutter, who shared the 2011 Nobel Prize for Physics for discovering dark energy, says he doesn't think anyone's getting overexcited just yet. But he says that's only because scientists are suppressing any premature elation, since they know that could go away once they get better data. On the other hand, scientists are taking notice because these two separate techniques are showing similar moderate disagreement with what's known as the lambda cold dark matter model. Now, according to the lambda cold dark matter model, dark energy is assumed to have the same strength over time, and it counteracts the gravitational contraction due to cold dark matter. But it seems other models which allow dark energy to change over time might end up being a better fit for what researchers are now seeing in the data. Needless to say, if that is the case, it will wind up having huge implications for the fate of the universe. Dark energy makes up almost 70% of the universe's total mass energy budget, and it's what's driving the universe's accelerated expansion. So, if dark energy is getting weaker, that would mean we would expect to see the expansion of the universe slow over time. So, what are the options? Well, if dark energy remains as strong as it currently is, or gets stronger, the universe will continue to expand forever into a dark future known as the Big Freeze, where all the other stars and galaxies are simply too far away beyond the cosmic horizon to be seen even with the most powerful telescopes. On the other hand, if dark energy eventually weakens and comes into balance with gravity, the universe will eventually end up in a sort of steady state, looking pretty much like it does now. But there's another possibility. If dark energy continues to weaken and gravity eventually takes over to become the strongest force, that would cause the universe to begin to contract, eventually ending in a big crunch, which could lead to another big bang, then another big crunch, and so on. It all depends on this balance between dark energy and matter. And it's one of those ultimate questions of science which make astronomy such fun. Astronomers want to find out which one of these hypotheses are likely to win, and they want to understand this underlying piece of the universe. Union 3 standardizes some 2,087 supernova events taken from 24 datasets, and they can be used to look back roughly 7 billion years through cosmic history. It builds on the earlier Union 2 experiment released in 2010 that contained 557 supernovae. In order to combine supernovae from different datasets, astronomers decided to analyze the light curve. That's the way the supernova's brightness characteristically peaks and dims over its life. And that lets scientists discover a supernova's intrinsic brightness and adjust the event so that they're all on the same scale, a bit like calibrating candles from different manufacturers. Scientists then reanalyze their supernova data using a sophisticated statistical method known as a Bayesian hierarchical model. This can better account for uncertainties, incorporating partial information and the probability of errors. It makes it possible to include factors researchers might not know exactly, but with constraints on exactly how well they do know them. For example, the new approach can take into account that the filters in a telescope might drift over time, changing the amount of light that gets through from a supernova. This kind of flexibility improves the accuracy of the analysis, and it was difficult to include in previous techniques. The improved analytical approach will now be used to incorporate additional supernova data. Over the next year or so, astronomers plan to add 3 more datasets, one with low redshift that is nearby supernovae, and 2 with high redshift supernovae looking further back in space-time. The new analysis framework will also help to incorporate the tens to hundreds of thousands of additional supernovae expected from the Vera C. Rubin Observatory, which recently released its first images, and also from NASA's upcoming Nancy Grace Roman Space Telescope. The other current leading technique to investigate how dark energy varies over space-time is by measuring how galaxies cluster, a characteristic feature known as baryon acoustic oscillation. Baryon acoustic oscillations are sort of like pressure waves through the fabric of space-time. Stars and galaxies tend to cluster around these pressure waves. Perlmutter says baryon acoustic oscillations can look further back in time to when dark energy played less of a role in the universe, while supernovae are especially precise in the more recent universe. He thinks the 2 techniques are now getting good enough so that astronomers can start making some real conclusions about dark energy models. This is space-time. Still to come, a new study shows that molten magma persists on the lunar surface much longer than expected, and Europe developing a new space weather early warning system. All that and more still to come on SpaceTime. A new study suggests that molten magma may have persisted on the lunar surface far longer than previously thought. Researchers analysing moon rocks from China's Chang'e 5 sample return mission say the new findings are rewriting science's understanding of how the moon cooled. A report in the journal Science Advances claims these samples of basalt, an igneous rock formed from rapidly cooling lava, represents the first material collected from the lunar far side and is by far the youngest obtained on any lunar mission. The study's lead author, Stephen Alado from the University of Florida, says that makes these rocks an invaluable resource for studying the moon's geological history. It seems that lava on the lunar far side probably cooled far later than previously thought. That contradicts previous theories on how and when the moon's layers formed. Elido and colleagues used radioactive dating to put together a simple model showing that an enrichment in radioactive elements would have kept the moon's upper mantle hundreds of degrees hotter than it would have been otherwise, even 2 billion years ago. In order to get an estimate of when these samples cooled into basalt, the authors tested their chemical composition. Now, similar tests on previous lunar mantle samples found traces of elements like potassium, thorium, uranium and phosphorus, all of which produce heat in high concentrations. Scientists believe that, in large amounts, these elements generate enough heat to keep magma molten near the Earth's surface, slowing the cooling process over time. The findings therefore contradict the previous theory that the moon's surface temperatures were simply too cold to support molten magma by that time, and it therefore challenges existing hypotheses about exactly how the moon would have cooled. Now, prior to this study, the generally accepted idea was that the moon cooled from the top down. It was presumed that magma closer to the lunar surface cooled first, as the surface of the moon gradually lost heat into space, and that as you descended closer to the lunar mantle, you'd find basalt rocks that cooled more recently than basalt at the crust. And that theory was backed by seismometers that were placed on the moon during the very first Apollo moon landing mission. But the new findings suggest there must have been pockets of surface-level magma late in the lunar cooling process. Elido says that lunar magmatism, which is a record of volcanic activity on the moon, provides a direct window in the composition of the lunar mantle, which is where lavas or magmas ultimately come from. He says scientists don't have any direct samples of the moon's mantle like they do for Earth, so their window on the composition of the lunar mantle comes indirectly from its lavas. Establishing a detailed timeline of the moon's evolution represents a critical step towards understanding how other celestial bodies form and grow. Processes like cooling and geological layer formation are key steps in the life cycles of other moons and small planets. And as Earth's closest neighbour in the solar system, the moon offers the best chance we have of learning more about these processes. This is SpaceTime. Still to come, Europe developing a new space weather early warning system. And later in the science report, researchers develop a new type of electronic wristband device which uses fine hand movements in order to control a computer. No more keyboards or mice. All that and more still to come on SpaceTime. The European Space Agency is developing a new early warning space weather probe designed to monitor the Sun from a unique position. Called Vigil and slated for launch in 2031, the spacecraft will be the world's first space weather mission designed to permanently base itself in the Lagrangian L5 position between the Earth and Sun. Lagrangian positions are gravity wells where the pull of two celestial bodies, in this case the Earth and the Sun, tend to balance each other out. It allows a spacecraft to hold its position in one of these locations without expending a great degree of fuel in order to maintain point. There are 5 Lagrangian positions. L1 is between the Earth and the Sun. It's where spacecraft like SOHO are based. L2 is on the opposite side of the Earth to the Sun, the Earth's night side, and that's where spacecraft like the James Webb Space Telescope are located. The L3 position is on the opposite side of the Sun to the Earth. L4 is 60 degrees ahead of the Earth and in the same orbit as the Earth as it goes around the Sun. You find a lot of Trojan asteroids at this position. And L5 is 60 degrees behind the Earth, also in the same orbit as the Earth as it travels around the Sun. And that's where Vigil will be located. From this unique vantage point, the probe will allow scientists to see solar activity days before it reaches Earth, drastically improving our forecasting abilities. From there, Vigil will literally be able to see around the corner of the Sun, observing activity on the solar surface days before it rotates into view from the Earth. And it can also watch the Earth-Sun line side on, giving an earlier and clearer picture of solar flares and coronal mass ejections as they head towards the Earth. Radiation, plasma and particles flung towards the Earth by the Sun, collectively known as geomagnetic storms, can pose serious threats to the critical infrastructure modern society relies on. This includes damaging or even destroying spacecraft, disrupting communications and navigation systems, overloading terrestrial power grids causing blackouts, and increasing radiation exposure for people in space and even those in high-altitude aircraft. In fact, a report by Lloyd's of London estimates that a severe space weather event caused by solar activity could cost the global economy $2.4 trillion over 5 years. And ESA's response to this growing threat is Vigil, cornerstone mission of the agency's space safety program. This report from ESA TV.
Solar storms can damage satellites, knock out power grids, and disrupt communications, GPS, and aviation. So, how do we protect Europe and the world from the sun's fury? Meet Vigil, the European Space Agency's space weather reporter, stationed deep in space to deliver early warnings of solar activity. When the sun launches bursts of radiation, plasma, and energetic particles toward Earth, the effects can be severe, even disrupting everyday life. We need timely space weather forecasts to protect people and safeguard vital systems. ESA's space safety program is sending Vigil to watch the sun and Earth from the side, giving it a unique view of solar eruptions heading our way. From this special vantage point, it will report 24/7, streaming data back across millions of kilometers. This data, combined with information from satellites closer to Earth, will give us time to react. It will power forecasts and real-time alerts, helping space weather forecasters, infrastructure operators, and decision-makers to respond quickly. As Europe's and the world's first deep space weather mission, Vigil will be our frontline correspondent on solar activity, strengthening Europe's independent ability to prepare for and respond to space weather.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has shown that the brain's aging has sped up during the COVID-19 pandemic, even for people who didn't have the virus. The findings, reported in the journal Nature Communications, used brain scans from nearly 1,000 people participating in a long-term UK health study to estimate the difference between a participant's real age and the age their brain appeared in a scan. Over half of the participants had 2 brain scans taken at least 2 years apart before the pandemic, while the rest had 1 brain scan before and 1 after the pandemic began. The authors found the brains of the pandemic group aged about 5.5 months faster than the control group over a period of about 3 years, with men, people under financial stress, and those with poor health likely to age faster. The World Health Organization says more than 7 million people have now been killed by the COVID-19 coronavirus since it was first detected among workers at China's Wuhan Institute of Virology in September 2019. However, the Lancet Medical Journal estimates the true death toll is likely to be above 18 million, with some 775 million confirmed cases globally. Paleontologists have identified fossils of a 247-million-year-old tree-dwelling reptile which had a crest which was not quite feathers and not quite skin. A report in the journal Nature claims the reptile, which was not a dinosaur, appears to have developed an alternative to feathers long before dinosaurs did. The reptile, known as Myrasura grovergelli, had a 15-centimetre crest on its back, a bird-like head, and it lived during the Middle Triassic period. The crest consists of individual densely overlapping appendages. Each possesses a feather-like contour with a narrow central ridge. While real feathers consist of many delicate branched structures called barbs, there's no evidence of any such branching in the appendages of this reptile. Consequently, the authors believe that the structures on this animal's crest must have evolved largely independently to those of birds. Engineers have developed a new electronic wristband device which can detect your fine hand movements and use them to control a computer. A report in the journal Nature describes the technology as a potential alternative to using a mouse and keyboard. The device could ultimately replace invasive technologies currently used to assist people with mobility problems. It was developed by learning the wrist muscle movements of thousands of people, which allowed it to interpret actions such as handwriting to be more accurately understood by a computer. Apple's new iOS 26 operating system is now in public beta form for those who want to try it out. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
So the developer beta was actually about a month ago at the Worldwide Developer Conference, and everyone's been waiting for the public beta to come out, which was to be in late July. Well, that day has come, and I have now updated 3 iPhones, 2 iPads, and my Apple Watch, and a Mac with iOS 26, iPadOS 26, etc., the 26 designated versions, which stands for the year 2026. And that liquid glass effect is quite striking. I mean, this is the most visible change in the iOS and the Mac operating systems since it all changed back in iOS 7 when it went from the skeuomorphic design where you saw little pictures of various things to a much more sort of flat design, which annoyed people at the time because the text was so thin, the designs looked completely different to what they had before. And there has, of course, been concern that if you've got a transparent interface, then how are people with potentially vision issues going to be able to read text on the page? Now, there's only elements of the operating system when you pull down the notifications bar, for example, or you're looking at certain things where there are transparent elements. But of course, anybody with accessibility issues can turn the transparency off. And the actual way that certain apps are used has changed. So it's much more intuitive now to slide between different types of photographs or videos you want to take in the camera app, for example. If you look at the settings page, all the different settings there have all been spaced out that little bit further, which has caused, of course, some people to complain, oh, you're not using the space as efficiently as you were before. But look, I'm personally loving the new operating system. It seems to be extremely stable. I've been running the developer beta since version 1 on a secondary iPhone, but today I just installed the latest version and I've been greatly enjoying it. It seems very stable to me. I certainly would not recommend the average user put it on their primary phone. Not that I've had any problems, but it's just one of those things where if you have a spare iPhone and you want to play on that, by all means. If you like stability and you don't want any surprises on your primary device, then you're better to wait until September. And then, of course, there are some people that wait until the 0.01 or the 0.1 version comes out because they know all the bugs have been erased. Now, the big change for iPads is resizable windows, a pointer that's no longer a dot but an actual arrow, the ability to put windows anywhere on the page you want. It's sort of a big upgrade even for older iPads that couldn't use the Stage Manager feature from a couple of years ago that gave you resizable windows. This makes your iPad, even an older one that can, if it still can run iPadOS 26, feel much more like a computer as opposed to a content consumption device. But this is the system that everyone will be using if they have a compatible phone from September. So big changes in operating systems from Apple and the start of a new era. And so far, it's great.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.